Hello children, in this video we are going to learn about Lorentz force. What is Lorentz force? If a charge is moving in a perpendicular magnetic field, then the charge will experience a force. That force we call it as the magnetic Lorentz force. Right? Now you observe this diagram children. I have drawn here crosses which represent magnetic field as acting into the paper, right? Now you can see a charge q, it is moving along this direction. Say it is moving along x direction. See, this charge is moving along x direction. Now, and the magnetic field is acting into the paper, right? That is, it is acting into the paper, that is along z direction. Now what happens is, this charge, it will experience a force F perpendicular to both B and B. That is, already I told you, the charge, it is experiencing force along so velocity along x axis. Magnetic field is acting into the paper, that is along z axis. Now it will this charge will experience a force along this axis. You can see y axis, I mean. Now you can see this force, Lorentz force, it is acting perpendicular to both B and V, right? Magnetic field B vector and V vector, right children? So you can see the this F is acting perpendicular to V vector, and it is also perpendicular to the magnetic field which is acting into the paper, right? This is mutually perpendicular to each other. FVB, all the three are mutually perpendicular to each other. So what happens when this force comes into play? Now the charge which was moving in this direction, when this force acts, what happens is, the charge, it will change the direction. It was initially moving linearly in this direction. It changes its direction and it turns this way. When the velocity changes to this direction, again this F comes and act in this direction, right? Now F will act in this direction. Again, because of this F, the charge, it will move in this direction. Okay. So V is along this direction. Again F comes into act in the perpendicular to this V, F perpendicular to V. So what happened? The velocity of the particle, the direction of the particle changes in this direction, right? So V changes in this direction. Again F acts same way. Now the direction changes this way. Again F acts. Now what happens? V direction changes. Again here F acts. See, look here how the V direction changes. Every time V direction changes, you can see F is acting perpendicular to V. So you can see that the charge, if the length of this V vector decreases, what happened? You can say that the charge, it starts to move in a circular path, right? This is the action of this force, right? This force which is acting perpendicular to V vector and B vector, we call it as the Lorentz force. What is the function of this Lorentz force? It will make the charged particle to move in the magnetic field in a circular path. What I mean is, the Lorentz force, it gives the centripetal force so that the particle moves in a circular path, right? If you find it difficult to imagine this, you can imagine that you're in a room and the ball is on the floor, right? You imagine the ball to be an electron or any charge, right? The ball is the charge, right? For convenience, you imagine that way. Now the ball is moving. Whenever I say ball, it means the charge, right? When the ball is moving, at the time what happens is, your magnetic field, it is acting from the floor to the roof, right? You're inside the room, ball is rolling on the floor. Now the magnetic field is acting from floor to the ground. So what happens is, the ball which was moving in the straight line, linear motion, it will start to move in a circular motion, right? Because of this Lorentz force, right children? So Lorentz force, it gives the centripetal force for the charge to move in the circular path. Later we will come to this concept again. Now first we will see what is Lorentz force and what are the factors on this Lorentz force depends on. So what is Lorentz force? A moving charge in a perpendicular magnetic field experience a force. That force is called Lorentz force. And Lorentz observed that this Fm, Lorentz force, depends on three factors: the magnitude of the charge and the velocity of the charge and also the magnetic field. And he gave this relation cross product. Fm is equal to Q into V vector cross B vector. If you take the magnitude, you will get A cross B formula. You can use Q VB sin theta. Okay, I have rearranged and written it as BQV sin theta. Right? The magnitude of Lorentz force is this. From this equation, you can observe that relation between this Lorentz force F and these factors. Lorentz force is directly proportional to the magnitude of the magnetic field, directly proportional to magnetic field. More the magnetic field, Lorentz will be, force will be more, right? Then Fm is also directly proportional to Q, and Fms, Lorentz force, is directly proportional to velocity, magnitude of the velocity of the charge, and Lorentz force is also directly proportional to sin theta. What is theta? It is the angle between these two, V vector and B vector, right? So, and also you can say that another point is, already I told you this Fm, magnetic Lorentz force direction, it is perpendicular to both V vector and B vector, right? F is perpendicular to V vector and also B vector, which is acting into the paper. Okay, now that's what I repeatedly I was telling. This is perpendicular to, mutually perpendicular to each other. Fm is perpendicular to V vector and also B vector. Okay, now you know that this is the formula. F is equal to BQV sin theta, right? Theta is the angle between V and B. If the charge is moving along the direction of B, right? The charge is in this, magnetic field is moving down, okay, into the paper. If the charge is also moving into the paper, right? Otherwise, imagine B in this direction. Okay, V is also in this direction. What is the angle between V vector and B vector? That is 0, right? Theta is 0. Now if you put 0 here, what happens? Sin 0 is 0, that Lorentz force becomes 0. What I mean is, if the charge is moving in the direction of magnetic field, Lorentz force does not act, right? Lorentz force does not act when the charge and magnetic field moves in the same direction. It will act only when the charge is moving along perpendicular direction to the magnetic field. Keep it in mind, children. And to find the direction of the Lorentz force, you can use this right hand rule. Right hand rule, what is that? Already I taught you. You have to keep these four fingers, right, on the first on the first vector. V is the first vector. You keep, I will tilt the paper this way, right? You can keep these four fingers on the first vector so that the palm facing this second vector. V is the first vector, B is the second vector. So place all these four fingers in V direction. Palm is facing the B vector, right? Now what happens? You have to move, these four fingers should be curled toward the second vector, right? At that time, the extended thumb, you can see thumb is pointing out, okay, out of the paper, right? For this case, it is pointing out of the paper. I cannot draw out of the paper, that's why I have drawn in upward direction here, right? So this extended thumb gives the direction of Lorentz force, right? Okay, children, if the charge is positive, again I will repeat, four fingers should be kept on the direction of the first vector and the palm should be facing the B vector, second vector. You turn first curl the finger toward the second vector. The extended thumb, that is upward, okay, out of the paper now. Fm, that is the Lorentz force, is acting perpendicularly outward. And here if the charge is negative, this is positive charge and here it is negative charge. Negative charge, what happens is, how to find the direction is, however you are getting charge, force in this force Fm for the positive charge, you have to uh, make Fm charge for Fm Lorentz force for the negative charge will be in the opposite direction of this case. Okay, opposite of this, that is the only difference, because Fm is minus q into v cross b. Here Fm is q into v cross b. If the sign here minus sign, so that is Fm is acting in opposite direction. Okay, Fm is in positive direction, here Fm is in negative direction. Otherwise you can say that instead of using right hand rule, you can use here right hand, here you use right hand, here you can use left hand also, children. Now the same way, what will you do? F vector should be on the this forefinger along first vector, that is v vector, right? And you curl the finger towards the second vector, b vector. Now you can see the thumb is in the downward direction, which gives the Fm, right? You can positive charge and for negative charge, Fm will be in opposite direction. This is how